Hello students. In this video I'll be talking about the feedback, and I'll be discussing positive feedback, and this positive feedback uh, we have we have an amplifier, and uh, and we have the input, and we have the output. So uh, we'll give signal to the amplifier, and amplifier is going to enhance the magnitude of the signal. So if we assume that we are using here common base uh, amplifier, common base transistor configuration, we will have the output here, and then what we do is we give back a part of output to the feedback circuit, and then the output of this feedback circuit is given back uh, to the input of the amplifier. So this way, what we are trying to do is suppose we have an input, and we have an input signal like this. So what's going to happen here is when it will go through the amplifier, it will enhance its magnitude, so it will be amplified. Now this amplified signal will be sent back to the feedback circuit, and and what feedback circuit does here in this case, in case of the positive feedback circuit. So to understand the positive feedback to the system that I'm talking about, uh, if I assume that the input that we are giving to this amplifier has a magnitude of 2, and if I assume that beta for this amplifier is, say for example, 8, now beta will be the gain, and so what will be the output here? If I take, for the sake of argument, I'll get 16 here. Now this 16 will be given back to the feedback circuit, and let us assume that beta for the feedback circuit is 1 by 4. So in that case, here we have 16. When the output of this amplifier will be given to the feedback circuit, it's going to reduce its amplitude by 1 by 4. So here we'll get 4. So this 4 will be added to 2, and then again you will have beta is 8 for this amplifier. So 4, 6. So this 6 into 8 will give us 48 here, and then after that this 48 will come back, and we have to take 1/4 of 48, and that will be the feedback that will be given to amplifier again. Now the numbers that I have noted, they don't have any physical interpretation. They are just to understand the concept of positive feedback. So the point is obvious here, that in case of positive feedback, you have an input, you amplify that input through the amplifier, and this amplified signal is sent back through the feedback circuit, where its magnitude is brought down. And once the magnitude is brought down, so we can see that the output of this input has the same phase as that of the input signal. So the same will be the case here in case of positive feedback. So here we'll have a signal whose magnitude will be 1/4 of that of the magnitude that we have obtained at the output of this amplifier. So this is how positive feedback is introduced in an amplifier for continuously supporting the amplifier and enhancing the magnitude of the part of the input signal that's given to the amplifier. Now, the another part there's another kind of feedback that we can think about, and we call that feedback as negative feedback, and the concept is same. Now, in case of negative feedback, we make use of an amplifier, and this is common base amplifier, and we have the input, and then we have the output. So this common base amplifier has beta, and we have the input signal. Suppose this is the input signal, and we have, what we do is we obtain an output signal here, and what we do is we return part of the output signal to the feedback circuit like this. So this is feedback circuit, and so what happens here then finally we will have an output here, and that output will be subjected back to the input signal. So what happens in this case is you have a signal, you make use of an input signal, its magnitude is enhanced. So it is an enhanced magnitude of the input signal, and you can see that both input and output signals, they are both in same phase. Now, what we talk about feedback circuit here. Now, this signal has to be given back to the feedback circuit, and it has a beta, and we will have a beta for feedback circuit. But so if we assume that this is the input signal for for the for the feedback circuit, the output signal that we have obtained through the amplifier, we send it back to the feedback circuit in such a way that the output that we obtain here is out of phase. That means the output is something like this, and it will have a beta, say 1/4, what we talked about in case of positive feedback in the previous case. So what happens now is we are making use of the output signal that we have obtained by amplifying an input signal via a common base amplifier. And we understand that common base amplifier does not change the polarity of the input signal. So we have the output signal in the same phase. Then we send down the same signal to the feedback circuit. And what feedback circuit does here is it changes the polarity. The output that we obtain here in this case is out of phase. So when this signal that we have obtained here, when this signal will superimpose back to the signal that we have been introducing at the input of this circuit. So what it's going to do, it is certainly going to descend the magnitude of the input signal. So so the correlation that we can think between this the output that we have obtained here through the feedback circuit, it is certainly in out of phase with respect to the input signal. So when the two signals will superimpose, the magnitude of the input signal is uh, will certainly go down. So this process can continue, and continuously you are descending some magnitude of the input signal that we are subjecting to the amplifier. So I hope the idea is clear here, that we can have two types of feedbacks that we can think of utilizing in case of an amplifier. So one is a positive feedback and another is negative feedback. So in case of positive feedback, the overall magnitude of the input signal is increased, and in case of negative feedback, the overall magnitude of the input signal is decreased.